This call is now being recorded.
We're going to start with Momentum's worksheet now. Now, in this worksheet specifically, we're going to solve all the different types of momentum-related maths for M1. So let's start. We have to first understand the basics of momentum first. In M1 momentum, it's kind of related to physics, unless it has only one extra topic, which is impulse. That we are not taught in A's physics. Okay, that's the concept of A2 physics. But then again, kind of related to physics. For those who have already done A2 physics or is doing A2 physics, so impulse is again an familiar topic for you guys. Now, in cases for momentum, we're going to first understand the few scenarios and then we will move on to your question maths. Okay, now for example, in a random scenario, we're going to divide. Just 1 minute. Assalamu alaikum, Asif.
Walaikum assalam. Assalamu alaikum.
We're going to start with momentum. Okay, this is the same topic we studied in the last class physics, so it will be easier for me to explain over here. And after this, we will move on to moments tomorrow, and then we will stop the. We don't have anything else, and we will start the QPs from the next class. Okay.
QP means question paper.
That means you have to complete another worksheet on momentum that I'm going to upload right after the class. And that worksheet has to be completed by Monday because today I'm finishing momentum. Tomorrow I'll finish moment. That means you have to submit all these 2 worksheets by Sunday, by Monday actually.
So I have another worksheet to do. Whatever.
I know. That's the problem. I'm sorry for this. Maybe skip sleeping. Maybe skip sleeping for the next 1 month.
1 month? আমার এক্সামই তো আর 20 দিন মাত্র।
Skip sleeping for the next 20 days. And you can obviously not study during the exam, right? So skip sleeping for this week entirely.
বাচ্চা-কাচ্চাদের এত প্রেসার দেন তার জন্য আপনার হাতে আছে।
Okay, now I'm going to actually upload this in YouTube, so all these things will be automatically given to YouTube. So let's stick to maths only. Now, in this case, over here in momentum, I'm going to there are actually different scenarios for momentum. We have seen in the last class also, right? There are scenario 1, scenario 2, scenario 3. But to be honest, I cannot explain all the scenarios. Like in some cases, they might be moving towards each other. They might be moving away from each other. One object might be stationary. The other object might be moving towards the stationary object, right? After the collision, they might combine together and start moving with a combined velocity. So I cannot predict that what kind of situation they're going to give you in the exam, but I can give you a random idea, like how to actually make an equation for any kind of situations you're working on. Now over here, this is your scenario 1. I'm going to break this down into 3 sections again. This is for my before collision. This is during collision. And this is my after collision. Now for before collision, we can see that 2 objects are approaching each other. That means over here, I'm going to consider this one as mass 1, this one as mass 2. Obviously, in all the other situations, in during collision section or in after collision section, M1, M2, masses never change, right? Mass remain constant. This is the initial velocity of the first particle, initial velocity of the second particle, initial final velocity of first particle. final velocity of second particle. Now, in this situation, I can see that over here, the particles are moving in two planes, right? Towards right, towards left. That means this is a double motion situation. Momentum is a vector quantity. So I have to specifically consider taking one direction as positive. So for my simplicity, I'm going to take the direction towards right as positive. And you should always write this on top of your maths, that which direction you are assuming to be positive. So over here, in that case, this u1 is positive, u2 is negative, v2 is positive, and v1 is negative, right? According to your basic general law of conservation of momentum, it says that sum of momentum or total momentum before collision is equals to total momentum after collision. Okay, now for your total momentum before collision, you have m1 u1 plus, sorry, it won't be actually plus, even though for summation we're supposed to add momentums, but over here for momentum 2, you have this negative velocity. Momentum actually becomes negative because of the velocities. Mass is always positive. In order to make momentum negative, it is the velocity who is responsible. So you get minus m2 u2 equals to, this is going to be minus m1 v1 plus m2 v2, right? This is how you're supposed to arrange the equation for any situation they're going to ask you to work with. Now, this is one of the situations. Asif, do you have any problem from this part?
না আপু।
Okay. Now, this is your scenario 1, and this is your scenario 2. In scenario 2, what happens? The particles are no longer moving away from each other. They are now combined to each other. I think we already saw this in the next class, in the last class again. This is m1, m2, moving with a combined velocity v. In this situation also, I'm taking the direction towards right as positive. So the final combined velocity of the two particles after the collision is positive here, right? Now, in this situation, what happens? The right-hand side will remain as it is because I did not change anything on the right-hand side, right? Which is the before collision section. Sorry, left-hand side. So left-hand side will not change, but the right-hand side will change now because this time your V1 and V2 doesn't exist. Over here, every particle after the collision were connected to each other and was combined, like moving with a combined velocity. Right. So in this situation, when the particles are connected to each other, remember that even if the particles are separate from each other and moving with the same velocity, then we cannot add their masses and write only one V. That is not possible. But in this situation over here, when they're connected to each other and starts moving with a similar velocity, now we can write m1v and m2v. And in the next line, I'm just going to take v as a common factor from them. We can write m1 u1 m2 u2 equals to m1 plus m2 multiplied with v. Right, and that was scenario 2. In scenario 2, the only difference is that over here your particles are combined to each other and they are moving with a combined velocity. Right, that's why the left hand side of the right hand side of the equation looks a little bit different. The masses are added up with one combined velocity. And this is it. You need to know about the momentum. Now, after this, they also want to find out that what is the impulse exerted on this. Like over here, I can understand that according to the basic definition of momentum, the definition of momentum was that the total momentum before collision should be equals to total momentum after collision, provided that no external force acts onto the system. That means in this entire scenario for before, during, and after collisions, external forces like friction and resistance or air resistance would not be acting onto your system, will be considered as negligible. That means over here, why would the velocity of particles changes, or why would the direction of the particle changes? Because they exert forces on each other, right? These two particles are exerting forces on each other, and that is known as an impulse. Okay, let me just write this down. 1 minute. Now we are starting from impulse. Sadat, you missed the initial part, which is for the two scenarios for momentum, but you already saw this in the last class. So I'm not going to explain this again. So we'll just quickly move on to the impulse part, which is a new thing for everyone. You can just go over the recording again to watch this. But I already explained you this in the last class, so I'm not going to do this right now. Okay. Okay. Now, in during impulse is basically a situation that is involved in the during collision section. Okay. Now, in during collision, what happens? If I just focus on only one particle, right? This is maybe particle one before collision. Then this is the situation for particle 1 during collision and for particle 1 after collision. Over here, obviously, particle 2 is also present, but I'm not focusing on that, okay? I'm only focusing on particle 1. So originally, particle 1 was moving towards the right hand side with a velocity of u, and after the collision it changes direction to left hand side with a velocity of v. And exactly this change in velocity, even if the magnitude doesn't changes, the direction changes, right? The change in direction or change in magnitude of the velocity will create an acceleration, which means that during collision something happened to this particle 1 for which the particle 1 accelerated, and that's why there is a change in velocity now. Right. So over here, why would a particle accelerate? Because there's some external force acting on the particle. As we have already stated from the basic definition of momentum, that we are considering the resistive forces like friction, air resistance negligible, and is the only force that can act on this particle 1 is the force exerted by particle 2 on particle 1. Right? This is the force exerted by P2 on P1. Okay, particle 2, particle 1. Now, in this situation, you have to consider that there was no other forces acting on this particle, right? We considered all the other forces negligible. So over here, this is the only force that is acting on this particle. And this force is the resultant force now. Since there was no other force, so we can write for particle 1, resultant force becomes F. If there is a resultant force, we know according to our basic idea that if there is a resultant force, object is not in equilibrium, object is not in what is it? Object is not in balanced position, right? Over here, whenever the resultant force is not equals to zero, it has a magnitude, then there will always be an acceleration, right? Acceleration will also not be zero. And because of this force, object accelerates, and because of this acceleration, there is a change in velocity. Maybe the magnitude might not change, the magnitude might change, magnitude might increase, decrease, but the directions might change, right? Something will happen. This A not equals to zero means four things can happen. Magnitude might change or stay same or decrease or increase, or maybe the direction could also change for this velocity. Okay. Now, in this situation, how would I find out this, like the amount of force that was exerted on this particle? In this situation, the force that was exerted on this particle can be calculated as impulse. Can you guys just wait for 1 minute? Sorry. Okay, sorry, as I was explaining, this is what that impulse calculates, the amount of force that was exerted on particle 1. And again, understand that this amount of force will only be exerted on particle 1 for the time duration when particle 1 was physically connected to particle 2, right? And again, in this situation, for example, over here also, this is an after collision situation. After collision, they're just connected to each other. In this situation, they're not exerting forces on each other, okay? Only in this situation, they were exerting forces on each other. So, impulse can be calculated as force multiplied with time. And there's another equation for impulse. Because of impulse, what do you see? The final velocity and the after and the before velocity or initial velocity changes, right? So you can also find impulse as change in momentum, which is basically mv final minus initial, right? So you can use any of the formulas in order to find out the value for force or whatever something they ask you to find out, okay? Now you can obviously substitute them, Ft equals to mv minus mu also, in order to identify the value for force or time, where only the masses and velocities of that particle is given. Is there any problem so far in case for impulse calculation?
Which one is the formula?
I'm sorry, Asif, I couldn't listen to you. Can you repeat?
Which one was the exact formula?
Both are the exact formulas, right? You can use force and time duration to find out impulse. You can use the before collision, after collision quantities in order to calculate impulse. Now, it depends on the question, what they have provided with. In most of the cases, they provide you with mass and velocity, and they don't give you the force and time. So they use this equation very often than this one. So this is much more important than the other equation, Ft.
Okay.
Sadat, is there any question? Okay, I think doesn't have any questions, then we're moving on to your question paper. Okay. Now this is a question paper maths. So we're going to solve these questions in class. That means after, I mean, I'm going to solve this file. So you guys are going to solve another file for me. Okay, now it says that particle P has mass m kg and Q has mass 3 m kg. The particles are moving in opposite directions along a smooth horizontal plane. Smooth indicates what? There is no friction, right? That is what indicated by the term smooth. And they collide directly. Immediately before the collision, P has a speed 4u and Q has a speed ku, where k is a constant. And as a result of collision, the direction of motion of each particle is reversed and the speed of each particle is half. Okay, they have a lot of things to explain. So we will first draw a scenario for them. 1 minute. Now this is before collision, after, during collision, after collision, right? To be honest, for this maths, yeah, during collision will be needed as they have asked for the impulse on part B. Now it says that, for example, initially this is P and Q. They have different masses. P has a mass of K and Q has a mass of 3m. So P has a mass of m kg and this is 3m. Before the collision, the speed of P was 4u and speed of Q was ku. where k is a positive constant you have to calculate. And after the collision, the directions have reversed. Like in this situation, the directions have reversed, and the velocities are half, right? The speed of each particle is half. That means initially, if p was moving with 4, this will be moving with 2u, and it will be half k u meters per second, right? Q will be moving with half ku meters per second, half of the initial velocities. And now using this information, they want you to find out the value for k. So we can easily use the basic format that for part A, total momentum before collision is equals to total momentum after collision. For this total momentum before collision, we have m for u and 3m ku. Oh wait, sorry. I have to take direction, any direction as positive, right? So I'll take direction towards right as positive, which means this is positive, this is negative, and this is negative, and this is positive. So in that case, this 3mku is negative because the velocity there was negative, or speed there was negative, and this is equals to minus m multiplied with 2u plus m multiplied with half ku, pm. Right. Now I'll just simplify it. This is 4u, 4mu. This is 3kmu. This is going to be minus 2mu plus 3 over 2kmu. From this case, if I take all the three k's together and m's together, we have 4mu plus 2mu and 3 over 2kmu and plus 3 kmu. And from this, if I just invert the equation, because I want to find out the value for k, so k should be on the left-hand side for my equation. In that case, I have 3 over 2 is 1.5, 1.5 plus 3 is 4.5. So we have, what, 9 over 2 kmu, that's equals to 6mu. I can understand that mu and mu cancels each other out. Finally, you have the value for k as 6 multiplied with 2 divided by 9. That's 12 by 9. 12 by 9 is, I think, what, 4 by 3. Yes, 4 by 3. The value for your k is 4 by 3. That is a positive constant there, right? Is there any question regarding the calculations from part A?
No.
Sadat, are you still in class? Is there any problem? Yeah, I think there's some issues with Sadat. 1 minute. Okay, now in part B, they were asking that in terms of M and U, we need to find out the magnitude of the impulse exerted on Q by P. You have to understand that on which particle this impulse was exerted on, right? So in whatever particle this impulse was exerted on, according to that particle, or you have to use the informations for that particle. This was exerted on P by Q. That means Q was exerting the force on P, and because of that force from Q, P will accelerate, P will change its velocities, right, or change its direction. So you have to find out the impulse exerted on P by Q. You have to use the informations of particle P, not the particle Q. Right. So in this case, we are going to write it like this: that over here, Initially, particle P was moving towards right with a velocity of 4u. During the collision, particle P was subjected by a force to the left by particle Q. So this is the force exerted by Q on P. And after the collision, because of that force, particle P has reversed its direction and decreased its velocity to 2u. And now over here in this case, I'm going to I mean, for this maths, I've already declared that I'm going to take the direction towards right as positive, right? So for part B also, we will assume the same thing. As I've already declared that at the part A, so I don't need to write that statement again for part B. So I can just start with part B. And over here, mass was M. Right, I can consider right as positive means this is going to be negative. 2u is negative. And impulse becomes M, V, M, U. Over here, M 4u minus M minus 2u here, right? Because the initial velocity or the final velocity, wait, sorry. This is supposed to be, this was
উল্টা
final
হবে না?
velocity. Sorry, made a mistake. This was final velocity. So this need to be this and 4u. So which gives you minus 2u minus 4u. So you're going to end up getting minus 6mu. So this minus over here indicates that in this particle P, there was a force exerted to the left and we assume the direction to the right as positive. That's why a minus value came out, right? So this one indicates 6 mu kg meters per second to the left. Now again, you can get the same answer for in terms of particle Q also, because in general, they're always going, like according to Newton's third law, during collision, they're going to exert equal amount of forces on each other, right? So if particle Q or equal amount of impulses on each other, if particle Q was exerting an impulse on 6mu on P, then P will also exert an impulse of 6mu on Q. So if you have to use the particle Q's information to find out the impulse, you'll see that you will get the same amount of impulse, but only the direction will be positive. Because in terms of particle P, what happens? In terms of particle Q, what happens? Q was originally moving with K U, and during the collision, a force was subjected on Q in this direction, and after the collision, it will be traveling with half KU and with its directions changed, right? And it has a mass of 3m, 3m. Over here, there was another hint that we have to find out the impulse in terms of mu and not in terms of k, right? So I already found out the value for k, which was 4 over 3. So I can just directly write this is 4, 3. And this is half of 4, 3 is what? 2 over 3. Okay. Now, in this case, if I want to calculate the impulse, again, this is positive and this is negative. So it will be mv minus mu. So you get 3m with 2 by 3u. And this is going to be minus. I mean, this will eventually become plus minus 3m minus 4 over 3u. So you basically get 2u plus 4, so 2mu plus 4mu actually, which gives you 6mu, right, to the right. That means what? Impulse is exerted same, but if you want to calculate that in reference to particle Q, the only direction will get reversed, right? But for this maths, as I was only trying to find the impulse for particle P, only minus 6 will be a better option, because for particle P, this impulse was exerted to the to the right hand side, right? So, but then again, to be honest, they have not given you any diagram over here. Like the question, 1 minute, Asif. The question doesn't give you a diagram. You drew the diagram there, and you assume that particle P was moving to the right, particle Q was moving to the left, right? So according to your assumption, okay, particle P was moving to the left, and an impulse of 6mu to the left will act on particle P, right? But in someone else's assumption, for example, in terms of Sadat's assumption or your assumption, you might consider that as particle Q and that as particle P. So for this kind of equations where they have not given you the diagram, you can assume any direction, and according to your assumption, you're supposed to get the same value for impulse for the two particles, but they will have different directions, plus and minus, left or right. Yes, Asif, you can ask now.
As we consider left side as a negative, so here I should be minus m into minus 2u.
We consider the left to be negative, right?
Yes.
Are you talking about particle Q?
ফার্স্টের যে ক্যালকুলেশনটা সেখানে
Mm-hmm.
এখানে
So
তো
this is negative.
তাহলে এটা m এর সামনে মাইনাস হওয়ার কথা না?
Now, this is final velocity is negative over here, right? Initial velocity was positive. So you got the final velocity as negative. So you got minus 2 mu minus 4 mu, so which gives you minus 6 mu.
না আপু, এখানে যে -2টা
Hmm.
যে আছে এটা তো লেফট সাইডে,
Hmm.
তো এটার মোমেন্টাম
Hmm.
তো তাহলে লেফট সাইডে হওয়ার কথা, তাহলে মোমেন্টামের সামনে তো মাইনাস হবে না?
I mean, I wrote that minus to you, right? Momentum is negative because of velocity or speed. So that's why to me, like I wrote it like this, minus 2u. Like I wrote it separately that mass is positive, the momentum was negative because of 2u, right? Negative 2u. If you multiply them, then I can write minus 2mu in the next line. I just skipped that part.
Mass always positive.
Mass is always positive. Momentum is negative because of your speed.
Okay.
Okay, now this is it. We're done with this question. Momentums only have this kind of questions actually involved. Nothing more
But আপু
than
দুইবার
this will be
ক্যালকুলেট
asked.
করলেন কেন?
Oh, because I was just trying to show you that even though you calculate the same type of situations for particle Q, you will get the same magnitude but different direction.
Oh,
Okay, I mean, for this question, as they ask you to find out the impulse on P, that means you are supposed to do the working on this, and this was just an extra for the explanation. Okay, you're supposed to do the calculations in terms of particle P, not in terms of particle Q, because impulse was exerted on P, not Q. Okay, then let's start to solve the second question. In question 2, it says that a mass of 2 kg is moving along a straight horizontal line with speed 12, and the particle B of mass m kg is moving along the same straight line in the opposite direction with a speed a. The particles collide. The direction of motion of A is unchanged by collision. Immediately after the collision, A is moving with 3 and B is moving with 4. But it doesn't say that what happened to B, right? It says that A doesn't change its direction, but we do not know exactly what happened to particle B after the collision. So I'm going to assume that A and B, they are both moving in the same direction after the collision. Okay, that could also be one of the situations. This is during the collision section, and after the collision, this time, they are both traveling with the same velocities, so in the same directions maybe. So this is A, B. Mass of A was 2 kg and B was m kg, so this is 2m. A was originally moving with 12 meters per second, B was moving with 8 meters per second. And after the collision, it says that A does not change its motion, okay, or direction of motion, and it continues to travel with 3 meters per second, which means what? If A was behind B and A did not change its motion, that means B must have changed its motion, right? Otherwise, B would continue to travel to the right hand side. As this was a straight line road, that means B cannot slide past A, okay? If A continues to travel towards right, that means B must reverse its direction. And if B reverses its direction, then B is now moving to the left now, so to the right with a velocity of 4 meters per second. And now they're asking to calculate the value. Sorry, first they're asking to find out the magnitude of impulse exerted by B on A. Right? That means what? I'm going to use the informations of particle A to calculate this. So for part A, they're asking you to calculate the impulse on particle A. Now, it doesn't matter even after the collision, they start traveling in the same direction. During impulse, what happens? They will exert forces on each other in opposite direction according to Newton's first law, right? So over here, before collision, particle A was moving towards right with 12 meters per second and mass was 2 kg. During collision on particle A, a force was exerted by B on A in this direction, and because of that force, the particle decelerated, right? That's why the velocity changes, but it was not enough, big enough to make reverse that particle A. It only could decelerate that particle A and decrease its speed to 4 meters per second, whereas mass remains same. Now, in this situation, I'm taking direction towards right as positive, and over here, before and after collision, particle A was always moving towards right, and only a force of what is this? Only a force of F newtons in the negative direction acts on particle A. That means over here, the impulse will also be in the negative direction. So after the calculation of particle A, you're going to get the value for your impulse for particle A in the negative direction, because force and impulse are always in the same direction. So over here, I M V M U, which is going to be I M is what? 2 multiplied with 4, because this is positive, right? Over here, all the velocities are positive. Minus 212, and you get 8 minus 24. 8 minus 24 is 16. That's not 16, this is negative 16 kg meters per second. That means over here, impulse of 16 kg meters per second was exerted on A to the left. Is this clear? Any questions regarding this impulse calculation?
No.
Okay. Now in part B, they're asking you to find out the value for m, which is the mass of particle B. You can calculate that using that equation's total momentum before collision or after collision, or you can use an easier approach now. As I already know, that impulse for particle B will be the same magnitude but in opposite direction, right? So if you want to write this, that impulse for particle B in that case will be same but opposite direction, means this time impulse will be 16 for particle B, right? Because for particle A, a force was exerted on left. That means A will exert an equal magnitude of force on B to the right. And as force on B acts in the right direction, so impulse will also be in the right direction. Right was considered as positive, so impulse for B becomes positive. So we can use the equation mv minus mu equals to 16. Over here, m is just m, right? This is all we know. And before collision, initial velocity was actually initial velocity was actually minus for particle B. After velocity is positive. So we can write, or after collision, final velocity is positive. So m4 minus m minus 8, right? As I've already stated, this entire become negative because of this velocity. That's why I wrote minus 8 over here. This is equals to 16. So we get 4m minus minus, you get plus 8m. That's 16. So you're going to get 12m equals to 16, and after that you can get 16 over 12, which is what, 4 over 3. Right, so mass of particle B was actually 4 over 3 kg. Using this impulse, you can calculate the mass of the particle B in a very short few steps. Or if you want, you can also use the idea of total momentum before collision is equals to total momentum after collision. But that will just be more time consuming, because I think it takes more time to write all the momentum for particle A, B before collision, A, B after collision, and then substitute them, and then rearrange them, make m the subject of the formula. So that will just be a little time consuming. But you can also solve particle B in this reference, or part B in this reference, that sum of momentum before collision equals to sum of momentum after collision. But over here, it will be better to use this method, because in order to give you an indication about impulse, that's why they ask you to calculate impulse at the first stage. They wanted to use impulse for your part B. That's why they have given you the impulse in part A, and using this impulse, it will be better to use, like it should be better for you to use that impulse and calculate in part A, and then calculate the mass over here using that impulse. Is there any problem from this question too?
So can you explain it again, the part B?
Part B, yeah, sure. In part B, what happens? If I actually didn't do the diagram for part B, but if I just copy this part, I know that they are exerting equal amount of impulses during the collision, right? They always exert, sorry, 1 minute. They always exert equal amount of forces on each other during the collision. That means they're also going to exert the equal amount of forces on each other. Okay, just 1 minute. Now, in if I want to express this diagram in terms of particle B, the mass of particle B was m kg, and for particle B, a force towards right will be acting on particle B, which is a positive direction. Only the initial velocity, sorry, only the initial velocity of particle B is going to be negative because that was moving towards left. Otherwise, everything is moving towards right. Now, in this situation, according to your equation, I already know that during impulse for particle A and B, if B exerts a negative 16 kg meters per second impulse on A, then A will also exert positive 16 kg meters per second impulse on B. Right, according to Newton's third law, if B exerts 16 kg meters per second, A will also exert 16 kg meters per second, but in opposite direction. Is this clear?
Yeah.
Okay, then over here, as I was assuming the direction towards right as, sorry, right as positive, that means if A is negative, B will be positive. That's why we wrote impulse for B is positive 60. That means this much was applied on B to the right, and then the normal equation mv minus mu equals to 16. Final velocity was positive 4, so m multiplied with positive 4 gives you 4m, and initial velocity was negative 8. That's why you got m multiplied with negative 8. That gives you minus minus plus 8. And on the right-hand side, 16 will just continue. And after that, 4 plus 8 is 12. 16 over 12 is just 4 over 3. Is this clear, Asif?
Yeah.
Now we are done with this question 2 again. As I've already stated that for momentum, you won't see anything other than this in the question paper. Then let's solve question 3 also. I mean, they have a repetitive pattern. They're going to ask you to find the speed using the sum of momentum before after collision or impulse or anything regarding that. Or masses, right? These are the only things they will ask you to calculate. Now over here it says that two particles, A and B, are moving on a smooth horizontal plane where mass A is 2m and the mass B is m. The particles are moving along the same straight line but in opposite direction. That is a important point, that they are moving in opposite directions, and they collide directly. Immediately before they collide, the speed of A is 2u and the speed of B is 3u. Immediately, so the magnitude of the impulse received by each particle in the collision is 7 mu by 2, and you need to find out the speed of A after the collision and B after the collision. Okay. Now exactly, I do not know that over here if the directions are reversed or not, right? So I do not know exactly what happens after the collision. If particle A continues to move towards right, or if it's going to reverse its direction, I have no idea about it. So I'm going to assume something. Let's just remove, oh wait, we have to keep this because impulse is a matter here. This is also particle AB. 1 minute. Particle A has a mass of 2m and B has a mass of m. And they were moving in opposite directions before collision. And before they collide, their initial velocity was 2u meters per second and 3u meters per second. During the collision, what happens? An impulse of 7 mu divided by 2 acts on particle A, and an impulse of 7 over 2 mu acts on particle B, right? And then again, after the collision, to be honest, what happens, I do not know, but I'm going to assume this now again. I'm going to assume that since the mass of particle B was smaller than particle A, and also the initial velocity of particle B was bigger than particle A, I'm going to assume that A and B will continue to move in this direction. Okay, this is my assumption. They have not given me this information. I just assume this looking at their masses and combinations of velocities. Sorry. So I'm just going to consider this is VA and this is VB. Okay, this is my assumption here because they did not give me anything about this to assume it. Now, again, if I'm going to take the direction towards right as positive, which means this is positive, this is negative. Impulse on A is negative, impulse on B is positive. Final velocities of A and B are positive, right? So we have to use the impulse now to find out the final velocity of A and B because both the velocities are missing, right? And it was not a case that they are moving in a combined direction. So I exactly do not know if they are moving in a combined direction or not. So let's just assume they're not moving in a combined direction. So they don't have the same velocity over here. So I cannot use the total momentum before collision equals to total momentum after collision. That law over here, I cannot use that because using this law, I could only calculate one unknown quantity. And over here, you have two unknown quantity. So I have to use the equations of impulses over here. For part A, they want to find out the speed of A. That means we have to use the idea of impulse on A. So for part A, we're going to find out the impulse. Like we're going to use the impulse on A, which was according to my maths, it was minus 7 mu divided by 2, right? Because this impulse was exerted to the left and we took the right as positive. And particle A was always moving towards right. So for the before collision, after collision, it was always moving towards right. So velocities are positive for particle A. So we can write 2m VA minus 2m 2u equals to 7 over 2 mu. From there, if I write 2m VA minus 4 mu 7 over 2 mu negative. If I take this 4 mu to the right hand side, you have 2 MVA and minus 7 over 2 mu plus 4 mu, right? Which is what? Minus 7 is 1, is I think 3.5. Yes, 7 over 2 is 3.5 plus 4, that gives you 0.5 mu. So you have 2 MVA equals to half mu. I can clearly understand mass and mass gets cancelled out. And if you take that 2 to the right hand side, it will get divided with half. So you end up getting 1 by 4 or 0.25. The velocity is 1 by 4 m, so not mu, this is u meters per second. As you can see over here, the final velocity came out to be positive. That means my assumption about A was correct. If my assumption about A was not correct, then I would be getting a negative value over here. Negative 1 by 4 would have came. If I was assuming that after the collision, A would have reversed the direction, then according to this calculation, I would be getting a negative 1 by 4. So my assumption about A is correct. Okay. Is there any question about the calculation of impulse on A?
No.
Okay. If there is no problem, then we're going to do the same work for part B again. For part B, if you remember, for part B, the impulse was to the positive direction. Final velocity was in the positive direction, but initial velocity was in the negative direction, right? So I'm going to write impulse for B equals to positive 7 over 2 mu, and this is going to be mv. Part B has a mass m, so final velocity was vu, that was in the positive direction. Initial velocity was in the negative direction. So you get mvb. If you take this is going to be what? Positive 3 mu, right? If you take this to the right hand side, it will be 7 over 2 mu minus 3 mu. So you get 0.5 again. So vb, sorry, this is half mu. So masses gets cancelled out and you get vb as half u. right? And again, my calculation gives me positive value for velocity of particle B. That means the assumption that I did at the top, that was correct. And that's why if my assumption was correct, my values came out to be positive. Is this clear?
Yes, sir.
Okay, so this is it. We are done with question 3 again. Now let's move on to question 4. Just 1 minute. Okay, sorry. As I was explaining that in question 4, it says that two particles A and B are moving on a smooth horizontal plane, again indicating there's no friction here. And for mass of A is Ka, where it is given that K is in between 2 to 3, like greater than 2, less than 3. And B has a mass of M. And the particles are moving along the same straight line. Over here, the main idea about giving this range is to give you the idea that A has a larger mass than B, because B has only 1 m mass, whereas K might be having something greater than 2, less than 3 mass, right? So obviously A is heavier than B. And the particles are moving along a straight line, but in opposite directions. Again, this one is important. They are moving in opposite directions and they collide directly. Immediately before the collision, A has a speed of 2u and B has a speed of 4u. As a result of the collision, the speed of A is halved and its direction of motion is reversed. Okay, it says that after the collision, A's direction will be reversed, and um, find in terms of K and U the speed of B immediately after the collision. Okay, now it says in terms of K and U, that means you have to use the equation total momentum before collision, after collision, because if I was using um, the information just for impulse on particle B, then that will not be enough. Okay, so also I cannot even use impulse because I have not calculated impulse in anything before that, right? They have not also given me about the impulse. So I cannot use impulse this time. I have to use my equation total momentum before and after collision. So 1 minute. Again, over here also I have to assume things because I do not know exactly what will happen to particle B after the collision. It was already stated that particle A will reverse its direction. But this maths, this portion is not needed actually because it doesn't get involved anything with like during collision part. Okay. They were moving in the opposite directions, and after collision, A has reversed its direction, right? Just 1 minute. Okay, as I was saying over here, that means initial velocity of A was given as 2u and B was 4u. So this is 2u, this is 4u, taking obviously the direction towards right as positive. That means this will be negative and this will be positive. And after the collision, the speed of particle A was half. That means initially it was moving with 2. It will be just u here with a negative magnitude because it got reversed during this situation. And again, I'm assuming that over here, This particle B might have caused a larger force on A. That's why particle A got reversed and particle B would have traveled in the same direction. Okay, that is my assumption. This is VB in the same direction. Like it will remain in the same direction. Now, according to my assumption, let's see if it is true or not. Let's start solving part A first. So we're going to use the basic equation, momentum before collision, total momentum after collision. So for total momentum before and after collision, we're going to write that Km with positive 2u. It was supposed to be plus, but it will get a minus over here. So you have M4u, and then it will be minus Kmu minus MVB. If I take everything to the KMU side and make VB the subject, like MVB the subject, then we have minus KMU plus 4MU and minus 2K MU. I basically took everything to the right hand side and I took this to the left hand side to make VB positive. So we get MVB. We have KMU and minus 2 KMU, so which is going to be minus 3 KMU plus 4 MU. And from there, I can take M as a positive, as a constant there, or as a common factor. So which is going to give me 4U minus 3 KU. So masses gets cancelled out, and you get a value of this V, final velocity of particle B, as 4u minus 3ku, right? This is the only thing that you get. Other than this, you don't get anything out of it. And they also asked you that, you are supposed to find out an expression for final velocity of v. So you can write this as 1 minute. Yeah, 4 minus 3k, and I can also take that u as a common factor, right? So u 4 minus 3k. Is this clear? Any question so far? That means over here, as you can see that in this situation, the value for my V came out to be what? Kind of positive? Or is it? No, actually, if you can calculate this, since the value for your, okay, this is the expression, right? I do not know if this is positive or not. This is the expression. Now, using that, inequality for K, according to that inequality, K was less than 3, but greater than 2. If you take the least value for 2 also, that when the value for K is equals to 2, how much do you get for VB? You get U 4 minus 3, 2. Right, which is by the way 6. 6 minus 4 or minus 4 minus 6 is going to give you minus 2U. So this VB gives you minus 2U, which means what? And this is by the way for the value for K equals to 2. We know that value for K was not equals to 2, could not be ever equals to 2. It was greater than 2. You have to use theories now. 1 minute. That it is supposed like this, that if K is greater than 2, then your VB should also be greater than that minus 2, right? It should be greater than minus 2. That is, I can understand that. But if it is greater than minus 2, what is the sign over here? It has a minus value, right? I mean, in part B, they were asking you that how does the direction of particle B is after the collision? What is the direction of particle B after the collision? Now, over here, according to the given range of K, according to the assumptions of K, I got the value for V greater than minus 2 U. The minus over here represents that my assumption was wrong. I assumed that the particle B was moving to the left, but according to my calculations, I got negative value. That means for particle B also, it will get reserved after the collision. So it will get reversed, and after the collision, it will now travel towards right. It will not remain on the left, and it will not continue to move to the left. It now have reversed its direction. So you're going to write that since K is greater than 2, then your VB should also be greater than that minus 2. Right, which is by the way 6. 6 minus 4 or minus 4 minus 6 is going to give you minus 2U. So you're going to write that since We got VB greater than minus 2U. Therefore, assumption was wrong and particle B is reversed. Particle B has reversed its direction of motion after the collision. Is this clear?
Hmm.
Now, after this, in part C, it says that the value for K is given as 7 over 3 now, and you need to find out in terms of M and U, the impulse, the magnitude of impulse that was exerted on B. That means what? You have to use the informations for B now. So, for part C, this is particle B before collision. Just 1 minute, please. Okay, now over here for particle B, initially it was moving with 1 minute, 2U, say 4U, negative 4U, and this was moving with, if the value for K is now, I know it's directly 7 over 2, 7 over 3, then I can calculate that, right? It will be U, 4 minus 3, 7 over 3. This was the expression for VB. If you calculate this, it turns out to be maybe what? 7. 4 minus 7 is just 3. So you get minus 3U, right? So this is going to be 3U. And for particle B, a force will be exerted on this direction. Right? According to my diagram, a force will be supposed to act on particle B in this direction. Now again, over here, if I use impulse, which is MVMU, I mean, I got the value negative over here because my assumption was wrong, right? Otherwise, the magnitude is 3U, and according to my direction now, as I've drawn the correct diagram here, according to this is going to be positive, by the way. So this is M3U minus M, U was negative, minus 4U, so which turns out to be 3MU plus 4MU, which is going to be 7MU kg meters per second. That means impulse was exerted on B to the right, and we can assume the direction towards right is positive. That's why the 7MU is positive. Is this clear, Asif?
Hmm.
Okay, just 1 minute.